Welcome back, reinforcement learning. This session I explained reinforcing good actions by using the policy gradient algorithm. Reinforcing good actions in the policy gradient algorithm. In reinforcement learning, the primary goal or primary aim is to maximize the cumulative rewards. Okay, that is the main principle of the reinforcement learning. In policy gradient algorithm, it is also reinforcement learning approach. Its target also to maximize the cumulative rewards. How to maximize the cumulative rewards? It uh, train the agent to get to optimize the actions by maximizing the rewards through probability distributions. Okay, in policy gradient algorithm, the agent learns to select the best actions based on the probability distributions. Okay, in this topic, the key concepts is defining the objective, action reinforcement, and log probability and credit assignment. These four are key concepts in reinforcement good actions. In policy gradient algorithm, different policy gradient algorithms are available in reinforcement learning. Their main objective is to create the probability distributions or the possible actions in a state. They create the probability distributions or a possible actions in a certain state. The approach is instead of predicting the q values like a q learning, this provides this optimizing the policy functions for the states and corresponding state available actions. The approach is instead of predicting the q values like a q learning, they provide the they are focused on directly optimizing the policy functions. Okay, generally the policy gradient algorithms use the stochastic policies to explore the actions based on their policy distribution, probability distribution values of the actions. So the stochastic policies, they are mainly used in policy gradient algorithm. In first one is objective function. What is the main objective of the in reinforcement good actions by using policy gradient algorithm is they are define some object. That object is required, that objective is differentiable objective function with respect to the policy network weights. Okay, the policy gradient algorithm requires the differentiable objective function with respect to weights of the policy network. The objective is to maximize the expected rewards by adjusting the policy based on the action taken with the rewards received rewards. The policy network generally we are represented with pi theta of s. Pi is the policy, s is the state, and theta indicates weights. Here theta is the weights parameter. The theta parameter indicates the weights of the policy network. In training object is maximize the probability actions that results in positive rewards of the policy gradient algorithm. So for example, if we get the positive rewards in any state, then automatically the probability distribution of the actions are changed based on the received rewards. The objective function is the policy gradient algorithms require the differentiable objective function with respect to weights of the policy network. Here for example, here the four discrete actions are available in a state. The state is input to the policy network. The output is probability distribution of the corresponding actions. Here all are equal probability distribution values 0.25, 0.25, 0.25, 0.25. This is the initial state. Okay, all are deterministic probabilities. We select the sample action which produce the new state and new probability distribution function. In the next one is action reinforcement. Action reinforcement, it is used in either exploration. Okay, we are the all are unique uniform distribution, we select the sample randomly. Otherwise, it is a stochastic distribution, we select the highest reward action. So the action reinforcement, we select the good actions. To reinforce good action, the algorithm updates the policy based on the rewards received. So the last experience, here the consider the last experience, based on the last experience, you change the probability distribution of the actions. For example, in previous example, all are we have the 0.25, 0.25 probability distributions. If the last action, we select the randomly the last action, it gives the positive reward, plus 10 positive reward. In that change, the probability distribution function automatically change in next step, next iteration of this episode, that is the 0.17. See here, the state is input to the policy network, the output is in previous case 0.25, 0.25, 0.25. We selected randomly the fourth one. This is the sample action which produce the new reward. This is used to reinforce the action. It updates the policy distribution. So now the policy is probability distribution is 0.17, 0.17, 0.17, but the fourth one is produce the plus 10, the positive reward. So it is 0.5. So this is the reinforce good actions. So we get the positive reward based on the last action. We update the probability distribution of the actions. So this is the reinforce good action based on the samples selected and received rewards. Here the probability distribution values are between 0 to 1. So this optimizing raw probabilities can be unstable due to the range between 0 to 1, small range. So we are using log probability to overcome that problem. So it is stabilize the optimization by converting the multiplications into sums. So it reduces the numerical errors. So this log probability we are using in loss function optimization. So we are using log probability instead of probability distribution function, instead of general probability distribution function, to overcome the unstableness in optimization. The credit assignment also one of the step in reinforce good actions. The credit assignment is considered the which action leads the final reward, which action leads the final reward. Based on that action, we reinforce the good actions. Here not all actions in a episode deserve the equal credit. Which action leads the final reward, that is the highest, that is a good action, that is a good action. So objective of the function is adjust the reflect importance of action based on their contribution to the final reward. So the credit assignment, we give the credit to the action based on which one leads to the final reward. Which action leads the final reward, we give the good credit to that action. So the policy gradient algorithms are important in reinforcement learning to optimize the policy function with using credit assignment by using log probabilities to get the best optimal policy in reinforcement learning to select the best actions in a state. Thank you.